Okay, so let's talk about this first topic in terms of measurement. You've seen that we're talking about motion as a distance and a time. We could talk about motion as how far you moved or something. In the highway, you might give it like 20 miles an hour. But on a graph, we want to see how an object moves versus time in relation to some kind of a sensor like this motion sensor. The first thing we're going to take a look at is just some object that sits still. The roof is a great example. What I'll do is take this tool that I have that can sense, just like a police's radar gun, the roof. You can see this is a graph that has a time on one axis, and it's going to be how far that distance, the roof for instance, is from this detector. I'm going to hit the play button, and what's going to happen to that roof? It's going to be a certain distance, maybe 2 meters from here to the roof, and it's just going to stay that same distance. And so any object that's not moving has a typical graph that looks like this. Okay? That's a great example of a motion of some object that's not moving. Now what about something that is moving? If I start from over there and walk towards the sensor itself, and I'm going to get a little better example by having a nice big target that is a big board like this, and I'm going to walk towards that detector because that's going to help get a nice solid signal. What do you suppose is going to happen to that graph? At first I'm going to start far away. So will that be higher or lower in this? Ideally you're saying, yeah, it should be the farthest as you're farther away, and then as I get closer towards it, I should move my way towards the axis. So let's take a look as I move this board towards the detector. Okay? Yeah, I got a little noise because sometimes that's the way these instruments are. But you can see as I get closer and closer to the detector, my motion is downwards. That's motion towards the detector. Now, you may wonder what happens if it's faster motion. That's a certain, speed towards there. You saw it wasn't very fast. Let me try just going a little faster. What happens to that motion? Okay? What's the difference between these lines? I'm getting still closer and closer to that object, the motion detector, like the police radar gun. But this way I'm getting there sooner. And so what's happening between these? This is when an object is stopped. This is when it's slowly moving towards there. This is an object that is moving quite quickly. Is that slope is telling us about where and how fast that object is moving. Now, let's go to another kind of motion. What about moving away from the detector? I'm going to go ahead and turn these runs off so they aren't confusing the issue here. Okay, and I'm going to start close, and I'm going to walk backwards. So I'm going to actually let this run, and we'll just see how it's looking, and I'll clean it up a little. So here we go. We're going to start close, and that one should look how? I'm going to start close, so I'm going to get more towards here, and I'm going to move away. Nice even movement, and then I'll stop. And there you see my movement has stopped, and now I'm coming towards the detector. Okay, movement away from the detector, movement towards the detector. Okay, that's that kind of motion. Now, that's not the only kind of motion we can have. Sometimes we can get on and we can move with increasing speed. And so that would be acceleration. So I'll start walking slowly away, and we'll see how that's different from this kind of motion. Let me turn this one off again, and we can compare these. Okay, starting close is always nice because then I can start this, and then I'll speed up as I walk away. So here, let's take a look at how that looks. Okay, now I've got a lot of noise in there, but that's okay. You get this idea, is that this was the motion here, and then I got faster and faster, and then something crazy happened. I got some weird reflections. But this is a curved surface. As a matter of fact, something falling, well, I can even do it towards the roof to see if that's a little better way to show some speed. Let me turn that one off. And let's move to the ceiling with increasing speed. Okay. If I want, I can take a look at this motion. Let's make this expanded. Oh, I have the hang of this. you can see that my motion is changing and it's getting faster towards the roof. That is a good example of acceleration. Okay, non-straight lines are the way that, or curved lines are the way that things look like in a displacement versus time graph. So I'm going to ask you several questions on the worksheet about different kinds of motion and see if you can't come up with those, and we'll come back together and see how that went.